Hello, welcome to the Anthropocene lecture. The Anthropocene is a brand new epoch that's actually not an official epoch just yet. However, there's been a lot of discussion amongst biologists, geologists, and other scientists that this is perhaps a new epoch we should consider. So we're going to talk about it today. Before we begin talking about the Anthropocene, we should take a look at the different time periods in our Earth's history. If you remember from previous lectures, we talked about some other eras, periods in our past. Most of our history is found as the Precambrian era, which is all of this that you see here. The Precambrian essentially lasted from 4 billion years ago to roughly 543 million years ago. After that started the Cambrian period, which was the beginning of the Paleozoic era. So we had the Precambrian era, the Paleozoic era, and then of course the era of the dinosaurs, the Mesozoic. And after the Mesozoic began the Cenozoic. The Cenozoic era is the current era we are in. The Cenozoic lasts from roughly 65 million years ago to now. As you can see from this picture, the Cenozoic era is divided into two different periods, the Tertiary period and the Quaternary period, and each period is subdivided into different epochs. We have lots of different epochs. Most recently, the Pleistocene, and then finally the Holocene. It's the Holocene epoch that some scientists propose should be renamed to the Anthropocene. Other scientists propose that perhaps we should begin the Anthropocene about 100 to 150 years ago, and that the Holocene would have ended then. That's primarily what's the main point of debate today. The Anthropocene epoch was first proposed by a geologist, Paul Crutzen, in 2002. He noticed human activities were impacting the atmosphere, and that there was hardly a single area of the globe, the atmosphere, the land, or the oceans, that hadn't been impacted by people in a significant way. In this lecture, we're going to discuss the lines of evidence that Paul Crutzen had in support of the fact that we are currently in a new epoch touched by human activity. The Anthropocene would be so named because anthro means human and ocene is time period. So this would be the human time period. It's the one time period on Earth that a single species, Homo sapiens, would be the top predator all across the globe, including land and sea. There were times in the past where a top predator governed all of the land or all of the oceans, but never, as far as we can tell from fossil record, has a single species dominated both. The result of this is that many species in the land and the oceans have been impacted by human activity. This chart shows a relative abundance of the different types of organisms that are under threat and have gone extinct as a result of human activity. All of the organisms here in red are currently threatened. This includes a subset of insects, things like fungi, crustaceans, non-flowering plants, a huge portion of the flowering plants, mollusks, lots of fishes, and many reptiles. Down here at the bottom of the chart, you can see all the different organisms that have already gone extinct. Many of these as a result of human activity. This includes many hundreds of mollusks, birds, flowering plants, mammals, fishes, insects, amphibians, reptiles, crustaceans, non-flowering plants, and other organisms. Human activities have accelerated the rate of species extinction. Current estimates are that as a result of human activity, we are currently witnessing 100 to 1,000 times the normal rate of extinction. This mirrors, in fact, the rate of extinction seen during the time of the dinosaurs. If you reflect on this, you can sort of consider what it would be like to live during the extinction of the dinosaurs. It would be similar to the rate of death and species extinction that we see today. On average, 2 species go extinct every year. Just think about how many that will be in your lifetime. As a result of this, scientists have agreed that we are currently experiencing Earth's 6th mass extinction event since the advent and evolution of multicellular organisms. As I mentioned, this rate is as fast or faster than when the asteroid and supervolcanoes were causing the extinction of the dinosaurs. The primary reason for this extinction is not overhunting or climate change, as you may suspect, but the primary reason for this extinction and the threat of many species is a result of habitat loss, wherein humans have taken over and manipulated and altered the land so dramatically, either to live there or for agriculture, mining, or other purposes. Of course, there are some species that have gone extinct due to overexploitation or overhunting. Of course, the white rhinoceros was one of these most recent casualties. Giraffes have recently been put on the endangered species list for the same reason. Invasive species is another common reason why many species are threatened or going extinct. This happens when humans accidentally or intentionally introduce a species from a different part of the world, and without any predators or natural environmental impacts to keep the population from exploding, these introduced invasive species can overtake and eventually wipe out native species. Pollution is another cause for some organisms to go extinct. This could be water pollution, air pollution, heavy metal pollution on land, or others. And then, of course, there's climate change, the dramatic shift in the overall climate of our planet. This was one of the reasons for the Great Barrier Reef that has vanished in the last few years. This is a really interesting study in how human activity has impacted many organisms on Earth. The Great Barrier Reef is thought to be the equivalent of a rainforest of the ocean, with the biggest amount of biodiversity the oceans contain today. Unfortunately, in the last few years, we've seen 90% of the Great Barrier Reef become bleached and essentially die. This was a result of an increase in the acidity of the oceans from increased carbon dioxide levels in the atmosphere, as well as an increase in ocean temperatures, again a result from climate change. This 90% of the Great Barrier Reef that is bleached and essentially dead will take thousands of years to recover, if ever. One of the reasons why I consider this an important case study is you can take a look at these 2 newspaper articles that were essentially a year and a half apart. This one, as you can see, was published in January of 2016. And in it, scientists warn that they created a study that projected an unprecedented loss of corals in the Great Barrier Reef due to oceanic warming. If you take a look at the summary of their research, it states the coverage of living corals on Australia's Great Barrier Reef could decline to less than 10% if the ocean warming continues. Not a year and a half later, we saw exactly that, where a perfect storm led to the Great Barrier Reef bleaching. And as I mentioned, over the next 2 years, over 90% of the Great Barrier Reef suffered this bleaching and a coral reef death, exactly as the estimates and predictions had determined not a year and a half earlier. I mention this because some people consider scientific modeling to be inaccurate or too overzealous with alarmist studies. However, as you can see from this, the computer modeling could not have been more accurate. We saw a similar thing with computer modeling of flooding in Texas, Louisiana, and Florida as a result of increased and rise of sea levels as a result of climate change. And sure enough, that's exactly what we saw in subsequent hurricanes around Houston and parts of Louisiana and Florida. Since we're talking about climate change, let's continue along that line. Again, a major line of evidence of human impact on life on Earth today. Not only have humans impacted the biodiversity and overall living systems on Earth, but it's also impacted our overall planetary chemistry, most notably in CO2 levels. This graph is particularly informative with CO2 levels. In it, you can see recent studies of carbon dioxide concentrations on our planet over the last 1,000 years. CO2 concentrations have hovered around 280 parts per million. That means that out of 1 million different molecules in the atmosphere, 280 of them are carbon dioxide. What you can see is that this was fairly steady for roughly 600 years or so, and then there was a slight drop in CO2 levels around the late 1500s. What caused this tiny little drop? It turns out that this is perfectly correlated with the devastating deaths of millions of Native Americans in North, Central, and South America as a result of European immigration and conquest. Yes, Europeans did intentionally kill many Native Americans. However, most of the deaths that occurred during this time were a result of disease. Massive amounts of Native peoples in North, Central, and South America died from various European diseases like cholera, diphtheria, smallpox, and others. These deaths contributed significantly to a reduction in overall human population on Earth. And as a result of all of these deaths in the Americas, many of the farmland and habitat that humans were using at the time reverted back to their natural state, allowing plants to grow and sucking carbon dioxide back out of the atmosphere. As you can see, this lasted only for a few hundred years, until eventually the human population started to grow again, and especially as a result of the Industrial Revolution, caused CO2 levels to skyrocket. It was the production and release of fossil fuel gas, like that from coal, petroleum or oil, and natural gas, that contributed to this dramatic increase in CO2 levels. This graph is a little old. Today's CO2 levels are over 400 parts per million. We'll continue to talk about this CO2 level in our next lecture.